Hello, in this review, we are going to look at foundational mathematics concepts that may possibly appear in one exam or another. So here is a very simple tip for you before you start attempting these problems. You would want to pause the video and try each problem and compare with the answers. But first of all, before you start solving any exam, you look at the simplest problems in the exam, then you solve it. So if this was an exam for me, I observe that the fourth question is the simplest question for me. So I start with number 4. Okay. So I use the laws of logarithm because I am taking the sum here, meaning that I need to take the product because the bases are the same. So this is log 2, 5 multiplied by x is equal to log 2x plus 20. Okay. Now you can observe that the bases are the same here. So meaning that 5x is equal to x plus 20. Then we can solve for x. This implies 4x is equal to 20, so that x is equal to 5. And I am done. Then I can look at question number 1. Question number 1, you know that you have to know that sine a plus b is equal to sine a cos b plus sine b cos a. Okay, so we are going to use this formula. So sine pi over 6 plus theta is equal to, this is sine pi over 6 multiplied by theta plus sine theta multiplied by cos pi over 6. Okay. Now you know that sine pi over 6 is 1 over 2 cos theta plus cos pi over 6 is the square root of 3 over 2, then I multiply by sine theta. Now you can observe that 1 over 2 is common here, so I factor out 1 over 2. This is cos theta plus the square root of 3 sine theta. And this is exactly what we are looking for. So I am done. Okay. So we can take a snapshot and look at the rest problems. Okay. Now I can look at problem 2. In question number 2, you only need two things. One, know how to find the determinant of a 3 by 3 matrix. Also, need to know how to solve for a polynomial of third degree. So first thing, I write my matrix as x1, negative 2, then x, negative x, 0, 1, 0, negative x. Okay. So the parallel bars means the determinant. So first of all, I take the first two columns like this. This is x1, negative 2, x, negative x, 0. So the determinant of this matrix is equal to, so I take x multiplied by negative x multiplied by negative x, which is x power 3, then plus, this is 0 plus 0 minus. Now I take the product in the minor diagonals. This is negative, negative, this is 2x, and this is plus 0, and this is negative x squared. And we know that this determinant is equal to 0. So this is x squared, this is plus x squared minus 2x is equal to 0. Now, so therefore, we can factor out x here. This is x, and x plus x minus 2 is equal to 0, which implies x is equal to 0, or x squared plus x minus 2 is equal to 0. Now you can easily factorize this. We know that the product here is negative 2, the sum is 1, and the factors are 2 and -1. So this is just x squared minus x plus 2x, and then minus 2 is equal to 0. Okay, so x is common here. X minus 1 plus 2x minus 1 is equal to 0, and x minus 1, x plus 2 is equal to 0. Okay, so therefore x is equal to 1 or x is equal to -2. So for this determinant of the matrix, for it to be equal to 0, you need x to be 0, x to be equal to 1, or x as -2. Take a snapshot and we are going to continue. Now I can look at question number 3, where we are looking for the coefficient of the fifth term in the expansion of that. So you can be tempted, first of all, to expand this binomial expression. However, expanding it will be a bad idea because this is a very long expansion. So we are going to use the general term formula, which states that T r plus 1 is equal to n combination r multiplied by a power n minus r, then b power r, where n is the first term, b is that one. Now, in this case, we are looking at the fifth term, so we are looking at T5. So T5 will be equal to T. Now, this is R plus 1. We already have 1. We need 5. So meaning that this is T4 plus 1, right? In this case, our R is 4. And this will be 9 combination 4. And the first term is x power, that is 9 minus 4. Then we can have 1 over that, then power r, which is 4. Okay? Now, we are only interested in the coefficient, right? We are only interested in the coefficient, which is that guy. So, therefore, the coefficient is 9 combination 4, which is equal to, this is 9 factorial divided by 4 factorial. 4 factorial, 9 minus 4 factorial. Okay. Now, you can see that 9 minus 4 is 5 factorial. So I can expand 9 as follows. This is 9 multiplied by 8, multiplied by 7, multiplied by 6, multiplied by 5 factorial over, I can write 4 as 4 multiplied by 3, multiplied by 2, multiplied by 1, multiplied by, I maintain 5 factorial because I have 5 factorial here. This is 5 factorial. Okay. Okay, let us come here. So 5 cancels with 5 factorial. That is 5 factorial, 5 factorial. In case you are not using a calculator, so you can see that this is 4 here goes 1 time, 4 here it is 2, 2 and the 2 cancels. Okay, I have 3 here, which is 1, and 3 into 9, which is 3 times. So this is 3 multiplied by 7 multiplied by 6, which is just 21 multiplied by 6, which is equal to 126, and we are done. So this is the fifth term. Okay, now I can look at the last question, which says I want the sketch of this rational function. Now observe that the degree of the numerator is greater than the degree of the denominator. So we have to take the division first of all before we do anything. So I am going to use long division, that is x minus 1. I will divide it by x squared plus, this is 0x plus 2. So I am adding 0 because I have a square here and I have a constant. Okay, so we're going to say x into x squared, which is just x. So I will put my x here and take the product, which is minus x, then plus 0. And then I take minus, so x and x cancels. This is 0 minus negative x, which is just x, then plus 2. Okay, now x into x is 1, so this will be plus 1, and I take the product, which is x minus 1, and I take the minus, so this is just x minus x, which is a 0, then 2 minus -1, which is a 3. We can now write our function as x plus 1, which is x plus 1 here, plus the remainder 3 over x minus 1. Okay. Now, because we have that guy here, right? So this would be our slant or oblique asymptote. So I will write, which is y is equal to x plus 1. Okay, so I have that asymptote. Then now I'm looking for the vertical asymptote. So the vertical asymptote. Now the vertical asymptote occurs when the denominator is 0. So this is x minus 1 is equal to 0, which implies x is equal to 1. Okay? I have my slant asymptote. I have my vertical asymptote. Now I'm going to look for the intercept. So let us look for the y-intercept. So y-intercept 2 divided by -1, which is just -2. So this function has an intercept at 0, -2. Okay. Now x-intercept. Okay. You can see that this function will not have the x-intercept. Why? Because when at the x-intercept y is equal to 0, meaning that this is 0 is equal to x squared plus 2 over x minus 1. Okay, and this implies that what? This multiplied by that is 0. So x squared plus 2 is equal to 0. But this implies x squared is equal to -2, right? Okay, now we have -2 here, and therefore x is not a real number. Okay, so because we have this case, you can see that x is going to be the square root of a negative number, which is a complex number, but our function is defined on the real number. So this function does not have an x-intercept. Now let us go ahead and sketch the graph. So we can do that, which is 1. So this is our vertical asymptote, x is equal to 1. Now we can put the slant asymptote. You can see that when x is equal to 0, y is 1. So I have my 1 here, and when y is 0, x is -1. So I have my -1 here, -1 and 1. So the slant asymptote passes that way. Okay. All right. So now we have the y-intercept. So this function passes at 0, -2. So this is my 0, and let's say this is my -2. Okay. So what you can just do now, you can just test points, right? Pick any point here. You will discover that the graph falls under this curve. If you pick any point here, the graph falls here. So I can just go ahead and connect my graph like that. So it will go like that, and here it will just be like that. Okay. So this is how you sketch the graph of a rational function. Just a recap of what we have done. First of all, look at the degree of the numerator and the denominator. If they are equal or this is greater, you first divide. So I did the long division and found that it is x plus 1 with the remainder of 3. And I write this expression like that. From there, I take this, which is the slant asymptote. Then I find the vertical asymptote, and I find the intercepts, right? So in this case, it does not have a y-intercept. It does not have an x-intercept. It only have y-intercept when x is equal to 0, and connect the graph. And we are done. Thank you for watching. See you in the next episode.